Welcome to A-Level and AP Physics. In today's lesson, we will discuss how temperature affect the resistance and resistivity of conductors and semiconductors. This is very important topic to understand resistance and resistivity in detail. First of all, let's try to understand what is the effect of temperature on resistance and resistivity of conductors. So it simply means that we are talking about conductors now, and then we will talk about semiconductors. For conductors, we need to understand as we increase the temperature, means when we increase temperature, we give thermal energy to the atoms or to the sample. Electrons in the atom means electrons in the outer shell. These electrons, they will absorb energy. When they will absorb energy, mean when energy is enough, they will leave the atom. So we will say atom has been ionized. Now atom is ion and it has net positive charge because electron has left this atom, and this whole process we call this is ionization. So simply we can write down this process is ionization, means atom has been ionized. Ionization simply means there are more free electrons in the sample. Number of free electrons, we can simply say number of free electrons increases, means more free electrons in the sample. Now number of free electrons increases. If number of free electrons increases, it simply means that number density increases, means number of free electrons per unit volume increases. We can say number of free electrons, N is the number of free electrons per unit volume, or simply you can say this is number density. Number of free electrons per unit volume increases. If number of free electrons per unit volume increases, it simply means I increases as well, because I is equal to NQVA. If N increase, it means I also increases. If I increases, current increases, it means resistance decreases. So due to ionization, resistance is decreasing. So we can simply say resistance is decreasing. But this is the one factor. The second factor is when temperature increases, we can write down when temperature increases, vibration of ions increases. This is ion, this is ion. So you can see the vibrations increases, the effective area increases. Before ion is here, you can see here. Now when temperature increase, it starts vibrating, so it is covering this area, so effective area increases. So we can say vibrations increases. So vibrations of ions get stronger, they're vibrating more, so vibrations of ions increases. So this is one thing. As vibrations of ions will increase, electrons, they will collide with ions more often. So we can simply say number of collisions increases, means electrons will collide with ions more often. Number of collisions increases. So we can write down number of collisions increases. If the number of collisions increases, it means that the relaxation time, means when electron is not colliding with the ions, that will decrease. So we can say relaxation time decreases. Relaxation time means the time when electron is not colliding with ions, that relaxation time decreases. Or we can simply say resistance increases. Resistance increases. So we can simply say resistance increases. Due to ionization, resistance is decreasing, but due to vibrations, resistance is increasing. Now which one is the dominant factor? Dominant factor is vibration, so this has more effect. Dominant factor is vibrations. So this is more significant. So we can say this is more significant. This is more significant. So overall resistance, we will write down, overall resistance of conductors increases with increase in temperature. Now maybe you have question in your mind why resistance is not decreasing due to ionization. The reason is that for conductors, value of N is very high. For conductors, for metals, we call metals are good conductors. Why? Because N for metals, approximately this is equal to 10 to 29 number of free electrons per unit volume. Now if we increase temperature, number of electrons means number of free electrons will increase, but that effect will be not significant. Let's say if 1000 more electrons release, so what is the effect on this? No big effect. That's reason this is insignificant. So the dominant factor for conductors when temperature increases is vibrations of ions. That's reason overall resistance of conductors increases with increase in temperature. Now let's try to understand the effect of temperature on resistance and resistivity of semiconductors. Semiconductors, we need to understand some examples of semiconductors before I explain you the effect of temperature on resistance and resistivity. Semiconductors are material like silicon, germanium. These are examples of semiconductors. And semiconductors, they have resistance between conductors and insulators. They are not very good conductors at room temperature, but if we increase temperature, their conductivity increases. It means their resistance decreases. Now let me explain to you why the resistance of semiconductor decreases with increase in temperature. First thing we need to understand, when we increase the temperature of semiconductor, ionization will take place. Ionization takes place. When ionization will takes place, it means number of free electrons in the sample will increase. We will write down number of free electrons, means now there are more electrons in the sample, more free electrons in the sample. When number of free electrons increases, it also means that number density, means N is the number density, N will increase, means number of free electrons per unit volume increases. If the number of free electrons per unit volume increases, it means current will increase, because I simply is equal to NQVA. So N increases, it means I also increases. If current increase, it means that resistance decreases. So we will write down resistance decreases when temperature increases. Very similar to conductors. The second thing we need to understand, when temperature increases, vibrations of ions increases. We have already discussed in the last part, vibrations of ions increases, means they are vibrating more now. The vibrations of ions increases. Simply you can understand ions are densing now, so the effective area increases. You can see before ions is here, is covering this much area, but then it start densing, it start vibrating, so it covers this much effective area. Now it is very difficult for these innocent electrons to keep on moving in a straight line. So that's reason number of collisions increases. Number of collisions between electrons and ions increases. Number of collisions between, this means between electrons and ions increases. Ions increases. So it means now they're facing more resistance. Electrons are facing more oppositions. Electrons are facing more resistance to keep on moving in a straight line, to keep on moving forward. Simply we can say keep on moving forward. So there is more opposition, there is more resistance. So it simply means that resistance of semiconductor increases due to increasing vibration. Now we need to find out which one is the dominant factor among these two. So we have discussed two factors. One is ionization, the second one vibrations of ion. So which one is dominant? Due to ionization, resistance is decreasing, but due to vibrations, resistance is increasing. We need to find out which one is dominant. Dominant in this case is ionization. So this one is significant. So the effect of this one is significant as compared with the effect of vibrations of ions. Means resistance decreases more due to ionization as compared with increase in resistance due to vibrations of ions. Why is like that? If we look at N for semiconductors, N is very small. N is very small at room temperature. Is very small at room temperature, means at low temperature. So we can simply say at room temperature, because N is very small. When we increase temperature, more free electrons are in the sample, and that increases current in the sample. So this factor become significant, and this has been done by experiment. We have seen this one, we have verified this one by experiments. Means ionization is more significant, and this has been proved by experiments. So that's the reason this factor is significant. So simply we can write down, as temperature of semiconductor increases, resistance of semiconductor decreases. Let me explain to you this one with the help of graph between resistance and temperature. So let me explain to you. This is for semiconductor. So the resistance of semiconductor mean we have resistance on y-axis and we have temperature. Temperature is on x-axis and temperature is in Kelvin. If we sketch the graph, the shape of the graph is like this. Shape of the graph will be like this. So you can see it is decreasing. You can see when it is cold, semiconductor is cold, it has very high resistance. But when semiconductor is hot, means its temperature is higher, you can see the resistance is lower. And this is what you need to understand about semiconductor. I hope it is clear. Now also let me explain to you the graph for conductors. For conductors, this one is for conductors. So you can compare these two graphs. For conductors, again on y-axis we have resistance, on x-axis we have temperature, and this temperature is in Kelvin. Now if we sketch the graph, you can see and you can compare these two. The shape of the graph will be somewhat like this, parabolic. So you can see when it is cold, let me use different color. You can see when temperature is low, means conductor is cold, resistance is low, so at lower temperature. But when conductor is hot, you can see at this temperature resistance is higher. So resistance of conductor increases with increase in temperature, and resistance of semiconductor decreases with increase in temperature. Now we need to understand, in case of conductors, the significant role is by vibrations of ions. That is dominant factor. But in case of semiconductors, dominant factor is ionization, means number of free electrons.